For the last few years, artificial intelligence has acted like a brilliant but passive oracle. You can ask it to draft a weekly meal plan or write a complex Python script, but the system still stops and waits for you to actually execute the labor. This friction is known as the chatbot ceiling. Every generated output requires a human to copy, paste, debug, and manually apply it to the real world. To move past this, computer scientists had to solve a harder problem: granting a machine agency. This requires engineering an AI that can operate 24 hours a day, safely spend money, and complete multi-step workflows without human supervision. At Google I/O 2026, CEO Sundar Pichai announced that Google had crossed this exact threshold, launching models designed to execute tasks autonomously. Shifting from a machine that answers questions to one that executes labor alters the basic dynamic of human-computer interaction. We are moving from being operators to being directors. The first requirement to build an autonomous agent is a cognitive engine capable of processing information at a scale and speed that allows for real-time decision-making. This diagram illustrates the processing leap required for autonomy. While standard models in 2024 handled trillions of tokens, the massive spike on the right shows Google's Gemini 3.5 Flash processing 3.2 quadrillion tokens every single month. But processing volume alone is insufficient. DeepMind's Demis Hassabis detailed how their team shifted the AI from predicting text to simulating reality. With a world model called Gemini Omni, the system understands the intuitive physics of our environment. It calculates how gravity affects falling objects and how kinetic energy transfers upon impact. An artificial intelligence must comprehend physical rules and real-world consequences before it can be trusted to take autonomous action. A brilliant cognitive engine is essentially trapped without a way to manipulate its environment. It needs digital hands. This visualizes the Anti-Gravity 2.0 framework. It breaks a single human request into a cohesive plan, branching out to dozens of subagents. Tasked to build an operating system from scratch, 93 autonomous subagents wrote the core code, audited their work, and iterated over tests. What traditionally takes a human engineering team many months was completed by this swarm in 12 hours, costing less than $1,000 in API credits. Software engineering is shifting from human beings manually typing out code to directors managing autonomous multi-agent swarms. Granting a system the ability to act autonomously introduces immediate risk. You have to ensure an agent cannot accidentally drain your bank account or make unauthorized purchases. Looking at this security schematic, we see how the new Universal Commerce Protocol and Agent Payments Protocol provide financial guardrails. They establish tamper-proof digital mandates to ensure accountability between the user and the merchant. With these boundaries established, personal agents like Gemini Spark safely hunt for deals and purchase items asynchronously in the background. To bridge these digital agents into our physical environment, Google partnered with Samsung and Warby Parker to create a new interface, Audio-First AI Glasses. Instead of pulling out a phone, you can look at a cafe and ask your glasses to place your usual order. The agent launches DoorDash, navigates the menus, and orders the coffee. Removing the screen and keyboard creates a continuous, invisible layer of intelligence draped directly over the physical world. The new baseline for computing is asynchronous. You assign a complex goal, close your laptop, and the AI executes the labor while you focus on other tasks. The exact same agentic architecture that books your weekend plans is simultaneously scaling up to tackle massive global scientific infrastructure problems. Specialized agents like CodeMender now autonomously hunt down and patch critical software vulnerabilities across global codebases. This visualization shows systems like AlphaEarth and WeatherNext at work. By simulating a digital twin of the planet, these agents pinpoint a storm anomaly and forecast its trajectory days earlier than traditional human-operated models. These agents now actively shape and protect our reality. We are standing in the foothills of artificial general intelligence.